Okay, so the first thing that I'd like you to do before we get into a little bit more with arithmetic series is to take a look at those two warm-up problems. You should have the half sheet in front of you, and I would like you to find the sum of the given arithmetic series. Once you have number 1 done, please submit your answer to Edpuzzle. So in problem number 1, looks like my common difference is -4. So I'm going to go and find my 49th term. A sub 49 is going to equal 72 minus 4 times 49 minus 1. And we go to the calculator. And 72 minus 4 times 49 minus 1 gives me -120 for my last term. I now have everything I need to be able to use the arithmetic series formula. S sub 49 will equal 49 over 2 times A1 is 72 plus AN, in this case A sub 49, is minus 120. 49 divided by 2 times 72 minus 120 will give us -1,176. Please try number 2 and submit your answer to Edpuzzle. It looks like this pattern is plus 0.6 each time. My 136th term, A sub 136, will equal 17.9 plus 0.6 times 136 minus 1. Typing this in on the calculator, we get 98.9 for our last term. I now have everything I need, and I can say S sub 136 equals 1 over 36, not 1 over, 136 over 2 times first term is 17.9 plus last term is 98.9. Going to the calculator here, that will give me 7,942.4 for the sum of that arithmetic series. I'm going to pause the video. Please take out your unit packets, and I need you opening to page 15. Page 15 in the unit packets. So we're going to look at arithmetic series, but today we're going to deal with this in sigma notation. First of all, any series where the thing inside the sigma is linear, just some constant times your variable plus or minus some other constant, anything in that form will be arithmetic. Let me write this out. Any series in the form the sum as I goes from some number to some other number of AI plus B is arithmetic. Any series in the form the sum as I goes from some number to some other number of AI plus B is arithmetic. 3i minus 1, that's in that form. In fact, take a look at all 4 problems on this page. They all look like they're linear, something where we just have our constant times our variable plus some other constant. Well, let me try to prove this to you that this is arithmetic. I want to take a look at this sum. The sum as I goes from 1 to 40 of 3i minus 1. I really don't want to do this problem by plugging in 1 and then 2 and then 3 and then 4 and then 5 and then 6 and all the way up to 40. That's going to take a really long time. The fact that this is arithmetic will help us get there quicker. But let me start by plugging in just to show you what's happening here. This is 3 times 1 minus 1 plus 3 times 2 minus 1 plus 3 times 3 minus 1 plus 3 times 4 minus 1 plus, and this is going to go on for a long time. 3 times 1 is 3 minus 1 is 2. Next one is 6 minus 1 is 5. Next one, 9 minus 1 is 8. Then 12 minus 1 is 11, and so on. Yeah, this is definitely looking arithmetic. Because this is arithmetic, I can use my arithmetic series formula. S sub n equals n over 2 times a1 plus an. In this sum, as we're going from I equals 1 to 40, that means there will be 40 terms. There are 40 terms over here. The first term, a sub 1, I know. My first term is 2, but in general, I'm going to get my first term by plugging in my lower limit of my sigma. And I'm going to get 3 times 1 minus 1. That's 3 minus 1, that's 2. The last term. There are two ways we can do it. The annoying way is I can look at this pattern. I can do what we did last time and use my arithmetic sequence formula to find to write a formula and then plug in and get my last term, but there's an easier way. I already have a formula for this sequence of numbers. My formula is 3i minus 1. To find my last term, all I need to do is plug in that upper limit to my formula, and I can do 3 times 40 minus 1. That's going to give me 120 minus 1. That's going to give me 119. I now have everything I need to be able to use my S sub n formula. S sub 40 is going to equal 40 over 2 times a1 is 2, and an, my last term, is 119. Now we go to our calculator. 40 over 2 times 2 plus 119. This sum, written in sigma notation, should be 2,420. And the idea is, if these things are arithmetic, well, it doesn't matter how many terms there are. I can evaluate these sigmas by using my arithmetic series formula, which is so much faster than writing out all 40 terms over here and going. Let's take a look at this second example, and you're going to submit a couple answers here in Edpuzzle. First of all, tell me how many terms we have in that series. Well, I'm going from 1 to 26. That means there are going to be 26 terms. For the first term, you need to go and plug your lower limit into your formula. What is your first term? That should be negative 2 times 1 minus 1. Negative 2 minus 1, you're going to get negative 3. What is your last term? Well, to find the last term, I'm going to take my formula and plug in 26. Negative 2 times 26 minus 1, that's negative 52 minus 1. I believe that's negative 53. Again, now we have everything we need to be able to use our arithmetic series formula. S sub n equals n over 2 times a1 plus an. I want you to go plug in those numbers, your 26 for n, your negative 3 for a1, and your negative 53 for an, and find the sum of those 26 terms. S sub 26 is going to equal 26 over 2 times negative 3 minus 53. We go to the calculator. 26 over 2 times negative 3 minus 53, that is negative 728. Let's take a look at the next example. The sum as I goes from 3 this time to 40. I want you to think for a moment and tell me how many terms will be in this series. Did you say 37? Because 40 minus 3 is 37? If you did, not quite. Here's why. If I was going from 1 to 40, I'd have 40 terms, right? Well, then if I was going from 2 to 40, that would be 39 terms. So 3 to 40 is 38 terms. I have 38 terms over here. The problem is if you just subtract 40 minus 3, you're not really counting that bottom term at all. What we can do in general to find the number of terms in a series written in sigma notation, we can do our number on the top minus the number on the bottom, but then I have to add 1 to that to make sure I'm actually accounting for that number on the bottom. Going back to the previous example, the sum as I goes from 1 to 40. Well, 40 minus 1, that's 39, but add 1, we get 40, and yeah, it makes sense that that sum has 40 terms. Let's go deal with this one. There are 38 terms. To find your first term, you are not going to plug in 1 for I. Instead, what number should you plug in? You should be plugging in your lower limit. That's 3 times 3 plus 4. 9 plus 4 is going to give you 13. The last term. Yes, there are 38 terms, but that doesn't really matter here. The last term involves you plugging in your upper limit from your sum. Go plug in that 40 and tell me what you get for the last term. This is 3 times 40 plus 4. That will give you 120 plus 4, and your last term should be 124. Now I have everything I need to be able to find my sum. This is S sub 38. There are 38 terms over here. This will now look like N, 38, over 2, times my first term, which is 13, plus my last term, which is 124. Go to the calculator and tell me what that is. Let's see, 38 over 2 times 13 plus 124. This gives me 2,603. The sum of those 38 terms in that sigma notation, 2,603. Let's take a look at one more of these. To deal with this sum, how many terms are there? If we go do our top minus the bottom plus 1, 33 minus 10 is 23, plus 1 is 24. There are 24 terms. Please find the first term. The first term should be 7 minus 10. The first term should be negative 3. Go find the last term. Seven minus 33. Last term should be negative 26. Okay, go figure out the sum now. S sub 24 should equal 24 over 2 times negative 3 minus 26. 24 over 2 times negative 3 minus 26, that gives me negative 384. Negative 300, sorry, 48. If you add up everything in that sigma notation, you'll get negative 348. We're going to do a little bit of practice in a little bit, but before that, I do want to take a look at just a few word problems involving arithmetic series. So please turn to page 16. I'd like you to take a look at that problem on the top of the page involving making a house of cards. I want to figure out how many cards I need to have 12 rows over here. Well, let's see over here. That first row on the top has 1, 2, 3 cards. If I look at the second row, that is 1, 2, 3, 4, 5, 6. You have 6 cards in your second row, which means in your first 2 rows, you're going to have 3 plus 6. In your third row, it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9 more cards. So by the time you get to your third row, there will be a total of 3 plus 6 plus 9 cards. Now, if I want to go down to 10 rows, this is like saying 3 plus 6 plus 9 plus dot, 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 find S sub 12. Well, this is exactly what we did last time. We're going to use our S sub n equals n over 2 times a1 plus an formula. I know my n, I know my a1. You need to take a moment and figure out a sub 12, the number of cards in your 12th row. Please do that. A sub 12 is going to equal 3 plus common difference is 3 times 12 minus 1. The number of cards in that last row will be 36. So now we have everything we need to be able to use our S sub n formula. 12 over 2 times 3 plus 36. Go do it. I think that should be 234. It will take a total of 234 cards to be able to build a house of cards similar to what's shown in that picture. One more word problem. An outdoor amphitheater, like kind of an auditorium but outdoors, has 45 rows of seats. The first row has 89, and each row has 2 more seats than the previous row. I want to know how many seats there are in total. So the first row has 89 seats. The next row has 91 seats. The next row has 2 more 93 seats, and so on. I want to find S sub 45. You go do that. I'm going to need to know the number of seats in the last row. A sub 45 is going to be 89 plus common difference is 2 times 45 minus 1. 89 plus 2 times 45 minus 1, or 44, will give you 177. That means in the last row, there are 177 seats. So now, S sub 45 will be 45 over 2 times 89 plus 177. 45 over 2 times 89 plus 177. 5,985. The last thing you're going to do today. You should have a worksheet titled Section 11.4 Arithmetic Series Practice. This is practice with some series written in S notation and some series written in sigma notation. I want you to do problem number 1, submit your answer to Edpuzzle, then I'll show you my work for 1. Then you'll do 2, submit your work, I'll show you my answer, and all that. See what you can do in problem number 1 right now. A sub 40 will equal 2 plus 10 times 40 minus 1. 2 plus 10 times 40 minus 1 is going to give us 392. The 40th number in that pattern is 392. Hold on just one moment. Just one thing. Okay, never mind. Now I'm going to go do S sub 40. This will equal 40 over 2 times 2 plus 392. 20 times 2 plus 392 should give you 7,880. Please go do problem number 2. Okay, well, for this problem, I need to find my 10th term. A sub 10 equals negative 43. You're going up by 3 every time. 3 times 10 minus 1. Negative 43 plus 3 times 10 minus 1 will give you negative 16 for the 10th term. Going to our series formula, s sub 10 equals 10 over 2 times negative 43 minus 16. 10 over 2 times negative 43 minus 16, that is negative 295. Go do number 3. Not really sure what I'm going up by, so I'm going to do some subtraction on the calculator. 37 minus 15.3, 21.7. Let me make sure that continues working. Yep, I'm going up by 21.7 every time. A sub 30 is going to equal 15.3 plus 21.7 times 30 minus 1. 15.3 plus 21.7 times 30 minus 1 will give you 644.6. 644.6. Going to our S formula, S sub 30 will equal 30 over 2 times A1 is A1 is 15.3. AN, A30 is 644.6. That gives me 9,898.5. Time for a new pen. Go do number 4. This is an arithmetic series. Because it's linear inside, I know there are going to be 20 terms because I'm starting at 1. That's not too bad. My first term, 7 times 1 minus 3, that gives me 4. My last term, 7 times 20 minus 3, 140 minus 3, 137. S sub 20 will equal 20 over 2 times 4 plus 137. Typing that one in, 20 over 2 times 4 plus 137, 1,410. Do number 5. There are 28 minus 6 plus 1. There are 23 terms. First term will be 10 times 6 minus 4. 60 minus 4 will give you 56. The last term is 10 times 28 minus 4. That's 280 minus 4. That's 276. So, S sub 23 will be 23 over 2 times 56 plus 276. And that's going to give me 3,818. Last one, number 6. 18 minus 5 plus 1, 13 plus 1, there are 14 terms. Your first term, 7 minus 6.5 times 5. That is negative 25.5. Your last term is 7 minus 6.5 times 18. Negative 110. So S sub 14 should equal 14 over 2 times negative 25.5 minus 110. That will give you negative 948.5. And if you finished all this, you can spend the rest of the period working on the homework or the final exam review packet.